recording.
What is up? This is Florida Man Does Weather. We're the Florida Men. I'm Caleb Alvarado.
I'm Josh Evans.
So we're going to get started with what is going on right now. This is near Frederick, Oklahoma. We're using the Frederick, Oklahoma radar. Right now we've got two hail-producing storms over southwest Oklahoma. Right now one is over Duncan directly, and they've been producing some quarter-sized hail. My grandma actually lives out there. Just sent me a photo of it not too long ago. Nothing too serious right now, but we do anticipate that these cells are trying to merge and basically just increase their own tornado potential. They are moving into an environment characterized by low 70s to mid 70s temperatures and dew points well into the 60s, low 60s, some mid 60s at points. So the environment is there for these. The shear is there. It's just really a question of if they can fight the temperature inversion that is still present within the area. That's part of the reason why we don't have a multitude of storms going right now. There's just warmer air above all of these that's keeping everything kind of tempered and very isolated. We also have another cell. If you could transition to the Vance Airport radar, where'd it go? There it is. It's already in Kansas. This one was the first one to really go off in Oklahoma today, and it looked promising. Was warned for baseballs for a good portion of time, but it is now moved out of Oklahoma and is moving into Kansas, where we currently have mid 60s temperatures with some slightly less quality moisture. The dew points are in the upper 50s, sparsely in the low 60s. It is moving with the moisture advection, but it is slightly outpacing the moisture advection. A lot of storm chasers are on this one right now. Personally, I don't think it's going to be the real main show other than some structure. The structure has been beautiful on it if you've been able to catch any of the live streams. But I think it's mainly going to be a hail producer. And then later on tonight, near the surface low, which is elongated but still present. It looks like it's starting to close off in kind of that northwest central Kansas area. Those should fire some more surface-based convection along the dry line or the cold front up there. There's better forcing up there, a little bit lower moisture quality, but that is improving rapidly. So initially, those are going to be hail and wind producers because the lapse rates are so high up there, and the dew points are still fairly low. Too much of a dew point temperature spread for tornadoes at this point, but that could change as we go further into the night and that advection continues. So watch out for that pretty much through all of Kansas. And down towards Oklahoma overnight, there could be some interesting stuff firing even after these cells. We'll go over to the models now and see what's going on there.
Which one you gonna start with, Caleb?
Yeah, you got this part.
Okay. So this is a model cross section from the HRRR. Really cool thing that tropicaltidbits.com offers is when you run one of the American models, you have the opportunity to do a cross section of it where you can see the 3D representation of what the model is predicting on the map. So basically, you're able to see what's going on through all the layers. The 23Z HRRR has a large lone supercell coming out of Texas, crossing the Red River and moving into southwestern Oklahoma at about 8Z. 8Z would be about 3 a.m. Central Time, if I'm doing the math in my head correct.
I think you got it.
Because so it'd be about 3 a.m. And as you can see right here on the map where I've got the AB cross section, A being the start point of the slice, B being the back end, I sliced the supercell from the front to the back so we could have a 3D representation. You're seeing here, the purple is your omega value, so that is where there is lift in the storm, where the storm is basically, and you can see on the map, very primitive, low resolution with what we've got, but the HRRR is modeling a monster supercell coming into southwestern Oklahoma. We chose to share this because if you're familiar with the Lemon-Doswell model of a supercell thunderstorm, um, the principle of the Lemon-Doswell model is you've got your jet stream aloft and it gets disrupted by the updraft of the thunderstorm, and the dry air aloft actually comes down and wraps around the updraft of the storm, basically forming your rear flank downdraft. Um, what is interesting, albeit it's primitive with the HRRR here, is you can see that the model is crudely trying to represent an RFD as that updraft, which you can see in the gap and potential temperature share, as the updraft in that thunderstorm that it's modeling. As the model is modeling that thunderstorm, it's modeling a very strong rear flank downdraft wrapping around the base of that storm, and you can see how it's actually quite modeling well, where the wall cloud would be pretty well. We just wanted to show this because we thought this was particularly interesting. This is the first time I've seen the HRRR model a supercell with such clarity, at least with a 3D slice like that. So it'll be interesting. This is not a guarantee. This is not a forecast that this is going to happen tonight. The HRRR is just hinting that the potential is there. So it'll be interesting to see over the next few hours if some of the activity that's currently bubbling in North Texas actually gets rooted and pushes north ahead of that dry line. So that's something that we'll definitely be keeping an eye out because if actuality does follow the path of what the HRRR is suggesting, there could be a very large tornado. The potential exists. We're not saying it will, but the potential does exist for a large tornado in western Oklahoma overnight. So please be weather aware. Keep an eye. Keep your weather radios handy. Keep an eye on what's going on outside. Caleb, do
And
you want to talk about the 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 dry line and the humidity?
yeah, let's pull that up. So this is our moisture analysis as of 0Z, so 8 p.m. Eastern Time, 7 p.m. Central, today, April 1st. So those blue shades are generally going to be your 60-degree dew points. Once you get into the purples and the dark blues, you're talking upper 60s with those dark blues, 70-degree dew points with those purple colors. So what I want to demonstrate with this is just how wide the warm sector of this system is. All the way to the Mississippi River, already we are starting to get warm air advection ahead of this system. So that is why what happens overnight is going to be such a big player. And you can even see why the storms developed where they developed today. You see those little bulges towards the east within those blue lines. Those are dry line bulges. That is where a little bit more convergence tends to occur. And that is where our storms have fired, especially with the northern Oklahoma cell and the southwest Oklahoma cell near Lawton, Duncan, that area. Those were all dry line cells. Further north into Kansas, that's where the forcing is going to be a little bit more strong overnight. That is where you are likely to see a line of storms explode overnight. That could happen in Oklahoma later, or it could also be a cellular mode as suggested by that 23Z HRRR run that Josh just went over. But that will have implications on tomorrow's threat. Right now, we are at a moderate 4 out of 5 risk level for tomorrow, and that is mainly centered on Tennessee, Arklatex, Kentucky into southern Illinois.
Mm-hmm.
And the reason being is that the same shear environment that currently exists over Oklahoma and over parts of Kansas is trying to advect into that area. Now, the reason why that moderate risk is currently there is because we have a general dearth of storms over Oklahoma and Texas. So it is less likely that there's going to be clouds preventing daytime destabilization down there. Into Illinois, the risk is a little lower. We're at an enhanced, still the threat there for significant tornadoes, definitely more of a damaging wind risk. But if storms do not fire to the extent that they are expected to within Kansas, I would expect that threat to ramp up tomorrow there as well. The shear vectors, in that area are a little bit better aligned with the front that will basically spark off all the storms. It's a little bit better for discrete convection initially until everything grows upscale into a big line of storms like we just saw a couple of days ago. Everybody up there is very familiar with these lines of storms at this point. But further south, where that flood threat is going to be into Arkansas, the Missouri Boot Heel, Kentucky, parts of Western Tennessee, you do have a supercell risk there, regardless of how storms evolve tonight. The shear vectors are more aligned parallel to the front. It's kind of like this. So your front's coming in here, your storms are going to be leaving it like this. So they're going to be discrete initially, but they will have a tendency to run into each other, kind of like we saw in Mississippi on March 15th, where you would see, for example, Tylertown, Mississippi. They had an EF4 roll through with one storm, and then an EF2 roll through with another storm, and then I think an EF1 just to the east of town on a different storm.
Yeah, they're all.
That will likely happen with this setup tomorrow on April 2nd, but it is eventually going to transition to more of a flood threat because you're going to get storm after storm after storm. And once this front is there, it is going to stick around. It's going to be there for the third, where you have a slight risk. The shear is still similar, but it's more of a conditional thing because you just have so many storms there. They're all going to be competing for the same inflow. And then I think that risk even exists on the third, right? Same area?
Yeah, you know what? If we can go ahead and bring that up real quick.
Yeah.
Yeah, you want a day three?
Yeah, pull day three.
Yep, there's your day three.
So there is our day three outlook. Nothing too serious. What's really going to be the problem is this area is expected to get 10 to 15 inches of rain over the next 4 days. That is an incredible amount of rain. And the risk is there for a strong tornado if something can really latch on to the inevitable outflow boundary that's going to exist, because these are all going to be really a linear mess, but the shear is still going to be present for supercellular structures. So if a supercell can evolve on an outflow boundary just ahead of where all these storms are going, that could be a real serious problem. But this slight risk, currently, I think it is more hail and wind driven. I would tend to lean towards more of a hail risk. I think a lot of these are tend to be elevated behind that outflow boundary. Any thoughts from you?
I would agree. It's worth noting too. I wanted to add to what you were saying about if we go back to the back over here real quick. What you were talking about the reason why Illinois initially the northern region towards the Great Lakes is in the more of the enhanced risk is because I believe the forecasters are banking on that large storm complex coming into developing in Kansas as the moisture advects overnight and kind of working the atmosphere over a little bit. Like you were touching on earlier, though, I do think that if for some odd reason that mode does not go off and that linear mode of storms does not fire, um, and you remain relatively sparse, kind of like we've seen in Oklahoma today, then I could see uh, potentially the threat increasing for Illinois. Like you were saying, as we look towards day three, the atmosphere is going to be really worked over. You've got your moisture still advecting in out of the Gulf at that point, so you'll still have ample moisture. But I'm with you on the tornado threat. You might get some areas where you'll get like just the right ingredients where a storm is able to take advantage of the shear and get some spin going. But I think mainly it's going to be rain, hail threat, excessive amounts of rain. Um, if you have basements, if you are watching this and you have basements up north, make sure your sump pumps are working because you will possibly be seeing some water off of this one. Friend of mine up there went ahead and made sure he's good to go. Other people are making sure they're good to go. I would advise anybody in this area, particularly in the mountains, because you're going to be dealing with the topography enhancing the rain as well. You're going to run the risk of slides, river flooding. We've all we're all unfortunately way too familiar with what happens whenever a lot of water occurs in a valley in a mountainous region. So that's my main concern. Obviously, you're going to get a lot of rain in like Ohio and stuff. My big concern is these places that have already been rocked recently. West Virginia just got pounded recently with some severe flooding. A lot of communities are still in search and rescue mode in some spots. And then, Kentucky, Tennessee, all of these places there's going to be a lot of rain, and it's not going to be a good thing, Caleb.
Yeah, the only good news is your wildfire risk is going to decrease a lot. That's
Yes.
about it. That's about the only benefit this is taking. So let's take it to day 4 because we've got day after day of severe weather coming up.
Okay, let's look at. So here's day
So
4.
day 4, literally rinse and repeat. Same risk, same area, same rainfall probabilities. Those are going to be your worst threat off of all of this. I wouldn't be surprised if the Weather Prediction Center even issues a high risk for flash flooding at some point
Mm-hmm.
if they already haven't. But yeah, day 4, that system is really not going to move much. We're going to
Yeah.
just kind of have um, continued ascent, continued cyclogenesis. Even on day 6, you're finally going to get something to move east, but it's still going to be raining over there. So you're going to have pretty much a linear system after tomorrow. That's going to be the main mode is just linear, slow moving training storms with winds, maybe some small hail by day 5 Saturday. Day 6 through 8, that is going to continue to sag east, and the front is actually probably going to tilt more southerly with time. And that brings us to Florida by Tuesday. We might get some of this. I was watching the European model roll in earlier. We actually have a decent wind field by Tuesday.
Mm-hmm.
Surface winds probably out of the southwest. So moisture, not an issue at all. I mean, it's Florida. Moisture is almost never an issue. But above that, at 925 millibars, you have, I think, 30 to 35 knots of southwesterly wind. At 850, southwesterly again, 35 knots. And at 500 millibars, we have about 40 knots of shear going over us. So it's really unidirectional, but that can
Each
do
year.
a lot around here.
Um, and they do note, as you can see here on the SPC analysis, they do note that the models are disagreeing significantly, which is why if you see what I just scrolled over here for day 8, potential too low, some models are going as high as a 15% probability at day 8. Some models aren't showing anything. Um, some models are showing multiple rounds of storms, multiple, like a significant event for the southeast and into Florida. Some models are showing nothing. We're really going to have to wait and see, just to see how that develops over the next few days. See what the atmosphere does as this system interacts with the continental U.S. and as it modifies itself. Even it'll be interesting to see how that risk transitions and if it does transition to the south, like some of the models want to insist on.
And then after this period, looks like we're going to be in a bit of a lull on the severe weather side. It looks like a large scale trough is probably going to set up on the eastern half of the US. It's going to shunt moisture return for a little bit. So hopefully we'll get a couple of days of a reprieve from this very active pattern we've been having before we inevitably return to it. It is April. This is normal. This always happens, but yeah, just watch out. I think we should go back to the radar real quick as well. Let's check
Yeah.
in on Oklahoma one last time. I think we'll end it with a final radar check.
All right. So this is running off Vance Station.
So we are at 8:18 Central Time, back to the severe weather that is ongoing. And as I said, that cell mostly looks like it is a hail threat still. It's kind of competing. It looks really elongated, pretty strange. Is there a
Like
second
these,
radar up there?
looks like, I'm sorry,
Is there another radar up there? Like,
let's find out.
is Wichita a radar site? Yeah, pull that one.
Hmm. So it does,
Ooh.
it does look a little better on that. You got a few, beans trying to form there, trying to get that little eagle look.
Hmm.
It looks like this one, I mean, they're trying, but it's the southern mode is competing with that northern mode. You've got two cells and they're fighting with each other. I think this is
Yeah, that's probably a dead ball game right there.
I think it's like you were saying, it's going to be a health threat, but this northern component is competing with the southern. You may get, I mean, you could get a tornado out of it. It does show that there is not
Wow.
really much there in
Wow.
regards. Yeah, looks
If
like you're,
anything, it's probably pretty elevated.
yeah.
So that there is one caveat with that. So the way that southern cell is feeding into the northern cell, occasionally you can get what I like to call just a feedback loop per se. Your forward flank from that southern cell can sometimes add to the strength of the northern cell's RFD, the way they're feeding in. So if somehow it can run into a pocket of better moisture, that one might have some tornado potential, but honestly, I think it is hail threat now.
It does look like that northern mode is outrunning. If when you're under a loop, the northern mode is definitely outrunning the southern on this
Mhm.
system. So I don't think you're going to be looking at a merger there. I'm sure there's
Right.
probably some beautiful structure out there, but yeah, I'm
Oh
with you.
yeah.
Not looking so much like a tornado threat right now for this one. Some of these guys up here, they're starting to get feisty. It'll be interesting to watch throughout the night, see what they're going to do. Um, let's go ahead and drop the Frederick real quick.
Ooh, pull Oklahoma City. Wow. So those Frederick cells, the northern one died. It is 8:20 p.m. Central Time now. Those of you in Oklahoma and Kansas probably noticed throughout the day as those low clouds went away, the sky got pretty hazy. That's your temperature inversion. That is part of the reason why these storms have struggled. The other reason was a lack of forcing, but sometimes that lack of forcing doesn't really matter if you have a small temperature inversion. So this is what's known as the cap. This year it is super dry, as evidenced by all the dust in the air causing that haze. There's a very expansive drought in the Southwest US, and it's even creeped into Texas. So anytime you get that wind from the Southwest down at the surface over there, it'll usually translate to a wind overhead over Oklahoma in the Midwest. And that can sometimes hold storms off during the day. And then as we get into the evening, that starts to break down as your surface temperatures are a lot higher. Storms just explode through that, and they kind of did that today. This one in particular that is dying as of what is it, 9:34 Eastern, 8:34 Central. That one exploded with speed. It went from a little blip on the radar to about 35,000 feet in like 25, 30 minutes. It was producing hail, but now that it's gotten closer to Oklahoma City and I-35, it is just collapsing because of that inversion. The inversion is really tampered with the updrafts and their speed and their strength, and the storm is literally collapsing in on itself. And I'm willing to bet there's no new convection even firing down near Frederick right now.
And
And you can see it.
as you saw that it just expand the you could tell the inversion is getting stronger because the ground clutter expanded in the 931 to 933 Eastern scan update.
So explain that ground clutter as well.
So the inversion, so whenever you have the radar beam that comes out of the radar, it gets influenced by um, different changes in temperature and density in the atmosphere. And basically, the radar beam can reflect off of certain layers of the atmosphere, long story short, and it'll pick up things on the ground and reflect those back to the radar. So the radar, while it's a magnificent piece of equipment, can be dumb in that respect because it doesn't understand what's being reflected back to it. It just understands something's being reflected back to it, and it's programmed to think it's precipitation. So what does it do? It automatically assumes that it is seeing a storm, a cloud, rain, and you get this what we call ground clutter. We call it ground clutter because it clutters the radar as the beam bounces off the ground and bounces back to the radar site. Um, On days where the inversion is particularly strong, you can zoom in maybe one day this summer, Caleb, we get a chance to do it in the evening. On our
Mhm.
local radar site, since it's very close to the interstate, when the inversion is very strong, you can actually pick up the traffic on I-75 be as ground clutter, and you can actually see how fast the cars are traveling on the interstate, thanks to that inversion reflecting down to the surface and reflecting actually off the vehicles traveling on the interstate. And so what we were saying was that ground clutter field right there expanded in the screen in the frame update from the 931 to 933, and now we've just got a 935. The As that ground clutter field expands, that's telling us that inversion, that cap is getting stronger and stronger.
So let's even go down to KDYX. This storm was also severe warned at one point, and yeah, now it's just some heavy rain. There
Yeah.
might be a special weather statement out. I wouldn't be surprised to see maybe dime-sized hail out of that. But yeah, everything is dictated by the cap tonight. We've even got our dry line very, very apparent on the radar right there.
Right here,
That's
cutting
the
across. Yep.
feature of inversions. Usually you can see the dry line as a very thin green line, almost looks like mist on the radar.
There you go. It's
But
right here too.
yeah, there's the bulge I was talking about. That's why you had your storm. Go up to Kansas real quick. Let's check on the storm cluster that is evolving. Uh, Yeah, so we've got a decent cluster of supercells that are forming in central Kansas, and the ones in southeast Kansas, I honestly think won't make it much longer. They are going into an area of less moisture. We'll see about that, but honestly, I don't think that's going to last too much longer, especially the new cells that fired. That one might keep going. The southern cell looks to be pretty vigorous, and it is feeding off of moisture advection as well. So we'll see. That might just be a long-term hail threat. But wow, that's a reverse supercell. That is a definite leftover right there. That's funny looking. But yeah, you can see the stronger forcing is definitely within Kansas and Nebraska. There's a decent cluster going. We've got hail-sized peas. But yeah, we'll see. Arkansas might be pretty under the gun tomorrow afternoon, especially if storms don't fire in Oklahoma overnight, which seems to be the trend since that inversion strength has really picked up over there. Um, but what we have seen is those capping inversions have been stronger than models indicate over the Midwest and weaker than models indicate over the East, probably owing to the fact that the Gulf is still well above average warmth. So there's more moist air being drawn up, and it might be overwhelming the capping inversions. Josh, take it away.
We do have, as we were just scanning here real quick, there is a very large storm south of Minneapolis. As you can see on the algorithm, it's saying max probability of hail at 2 inches, probability of
Minneapolis.
severe hail at 100%. Um, yeah,
That ain't Minneapolis. Oh,
right
wait,
here.
what? I didn't know there was a Minneapolis, Kansas. What the heck?
Yep,
That's silly.
yep, and it's moving off towards the northeast, so it'll be passing well north of Topeka. But it is interesting to see all of these cells are starting to fire, and that's kind of what the HRRR was suggesting earlier. Um, was that it would be these storms would fire in this line and push further east into Kansas. Um, it'll be interesting to see if these storms can hold it together. Um, that one does look awfully potent. Let's take a look at the reflectivity of this thing. I mean, you're looking at 68.5 dBz. That's some very large hail falling in that storm. Now, do keep in mind that the radar scan is elevated at this point. So, Caleb, it actually looks like this one's trying to split.
Yeah, it's probably going to split up there. Those are all going to
But yeah,
be likely to be your hail producing storms in that area. Your dew points are in the 40s to 50s across that area. And the reason these storms are more numerous, it's a little bit closer to where it appears a closed surface low is trying to form. So you're forcing for ascent, you're forcing for those storms to become storms is much more present there than it is further south. So Kansas, that's where you're probably going to have those overnight storms. There's even severe storms up north of the low right now into Nebraska. Those are hail producers with low 50s, upper 40s temperatures. They were warned at least not too long ago. They might still be warned. Let's
They're
see. Yeah,
still
they're still
no, they're
warned.
still warned. They're still warned up here. Yeah,
Yeah, that's amazing. So that area right now, we have what city is that close to? Howard City. Is that close to Grand Island? Yeah. All right. Perfect. So right now, that area has 46 over 41, 46 over 39, 48 over 46, 48 over 46. It's you're getting cold hailstorms in Nebraska right now. It's a very, very dynamic, very interesting system. These storms are highly elevated, probably some very neat structure up there, lots
yeah,
of lightning. It's a fun time to be in the Midwest for sure. A lot of interesting stuff happening.
got some good inflow on them.
Hmm.
Yeah, there's definitely a good.
Yeah, good old flying eagle.
All right, Caleb, was there anything that we wanted to add to this before we wrap this evening's vlog up?
Um, if things hold together, if things start to look more potent for Tuesday, expect some storm chasing footage to be uploaded to this channel.
That is for
We
sure.
are going to figure out how to do live as well. We have to determine basically who's got the better hotspot for live scenarios. So expect a live test to occur at some point. But yeah, this is going to be it. We're gonna get some joint chasing going. A lot of things are coming in for the summer. Um, Florida is right now in what I like to call the Gulf heater pattern. We have an early high pressure system off to the southeast, and we're going to be baking in the 90s the next 2 days. So, if that continues more than it doesn't for most of April and May, I expect there to be possibly some early May tropical systems. If a cold front or a stationary front can go sit in the Gulf for a couple days, maybe something spins up off of that if we can get those water temperatures to heat up. Anything from you?
Yeah, but I was just gonna say, there will be some growing pains. Bear with us as we get used to this thing. We're good at the weather. We're not necessarily as proficient with live streaming and recording as we are with the weather, but we're excited to start this channel and to be sharing things with you guys on a regular basis. I know since we've just started it about a week ago, things have been kind of hit and miss. We're just trying to get things established. Me and Caleb have been having meetings, going back and forth, seeing what's the real vision that we want with this. We're fortunate to be working with some meteorologists who are kind of giving us some insight on things that they think would be good directions for us to go. Um, we have some that have offered to help give us insight and analysis as things go along. And yeah, we're excited. We're going to start as the summer progresses and we are able to set up a studio. We're going to start recording more frequently. Our goal is to, go live with Q&A sessions and at least post content at least 2 times a week by the end of summer. As we go into hurricane season, things will definitely ramp up. Um, Tropical cyclogenesis and hurricane-induced tornadogenesis is the two fields of study that me and Caleb both share. It is the focus of our research, so that's kind of our bread and butter, if you will. That will be uh, the main focus during hurricane season that you see us dig into. Obviously, in the spring, you have your mid latitude cyclones. So we're looking at mid latitude cyclones right now. But there, when hurricane season starts, you will really be having the opportunity to dig into what me and Caleb's field of study and expertise is. We look forward to sharing that with you. Um, we look forward to sharing with you our current location of study, which is the place we call the Spine in the center of the state of Florida. Um, it is a former an ancient beach line back when part of Florida was still underwater, way back in the day. And as a result of that being slightly elevated, sometimes we get some interesting things that happen there during hurricane season between what we speculate may be slight orographic ascent, along with just interior land heating. But we won't bore you with those details now. We'll show them to you whenever things get cooking in the fall. So, welcome aboard. We're glad you're here. Go ahead and give us a subscribe if you can. And things will get more refined as we get used to this, as we get used to sharing things. We get better streaming and recording tools. We get the studio set up. Who knows? One day you may even see us playing around with a green screen. Uh, that's all pending in the future. We got big plans for this. Welcome aboard, and we're glad you're here with us.